Moon. The most popular hypothesis about the formation of the Moon is the Big Splash hypothesis. According to this hypothesis, the appearance of the Moon was caused by the impact of a Mars-sized object on the planet Earth 4.5 billion years ago. It is assumed that the Moon was formed from a collection of bodies scattered around as a result of this collision. This protoplanet that hit the Earth was named Theia. According to supercomputer analysis, as a result of this collision, the heavy part of the impact and shock receivers, that is, their cores, remained on the planet Earth. Fragments of the outer crust of both planets are more widely scattered, meaning bodies composed mainly of silicate, which is much lighter than the core of heavy metals. Our planet is the planet with the highest density in the solar system. If we compare, the density of our planet is 5,515 tons cubic meters, and the density of the Moon is 3,346 tons cubic meters, that is, the Moon has 60% of the density of our planet. From this, it is possible to conclude that during the collision, a large part of heavy metals remained on the planet Earth. According to supercomputer simulations, a Mars-sized object impacting our planet at a speed of at least 9 kilometers per second would have thrown enough planetary material outside of Earth's Roche limit to form the Moon. The Roche limit exists for all objects in the universe that have a gravitational force. Whether the Roche limit is large or small depends on the weight of the object. The Roche border of the planet and the Moon is 9,500 kilometers long. The Moon can have a stable orbit only if it is at least 9,500 kilometers away from our planet. Therefore, only objects thrown at a distance of at least 10,000 kilometers from our planet can participate in the formation of the Moon. There are various theories about the origin of Theia. According to some views, the composition of the samples brought from the Moon is close to the chemical composition of our planet. So it is believed that it was a planet in the orbit close to the Earth in the solar system. Other views suggest that Theia and Earth were planets in the same orbit. There are also hypotheses that differ sharply from this. According to this hypothesis, Theia is considered to be a giant planet that is completely alien to the solar system. One of the reasons for such a wide variety of views is the composition of the Moon. There are still many gaps in the Big Splash hypothesis about the chemical composition of the Moon. The reason we talk so much about the origin of the Moon is because of this topic. It is possible to find answers to many questions related to our planet. There are many reasons why the Big Splash hypothesis has been discussed so much, one of them being that some of the samples brought back from the Moon have a chemical composition similar to that of our planet. Among the samples brought back from the Moon are rocks that were melted at very high temperatures. The remarkable thing about the samples melted at this high temperature is that such a high temperature is not observed during the process of formation of a small space body like the Moon. And after the process is completed, such a high temperature is observed. Such a high temperature can be created when an object the size of Mars hits our planet at high speed. According to some estimates, 50 quadrillion megatons of energy were released as a result of the impact of Theia on our planet, which is 10 trillion times more than the total nuclear arsenal of our planet. A sample of the Moon melted at high temperatures can be explained by this process. Here the question arises, why did not our planet completely disintegrate when a huge object the size of Mars hit our planet at high speed? The fact is that our planet is actually liquid. The core and mantle of our planet are in a liquid state. The average thickness of this hard shell, which only has a hard shell on the surface, is 40 kilometers. This thickness is nothing compared to the radius of the Earth, which is equal to 6,378 kilometers. Our planet is like a drop of water suspended in the air. Therefore, a body the size of Mars would not be strong enough to completely disintegrate our planet, since the interior of our planet is in a liquid state. In addition, according to analytical conclusions, the surface of our planet was covered with coal 4.5 billion years ago. This means that the outer crust of our planet, that is, the hard crust, which is currently estimated to be 40 kilometers thick on average, was much softer. There is a very high possibility that our current moon will be completely disintegrated as a result of a high-speed collision with a space body twice its diameter. The reason for this is that in the past, the inside of the moon was in a liquid state, but now it is in a solid state, that is, the temperature of the 330-kilometer core of the moon is 1,400 degrees centigrade on average. In conclusion, the melting temperature of iron is 1,535 degrees C, and at the temperature of the core of the moon, in other words, at a temperature of 1,400 degrees C, iron is in a solid state. Therefore, it is possible that the moon will completely disintegrate in a strong impact. Unlike the moon, the temperature of the core of our planet is 5,000 degrees centigrade, and at this temperature any element is in a liquid state. That is why when Theia hit our planet, Theia penetrated deep into the planet as if jumping into water. Because our planet is liquid inside, it easily swallowed Theia. According to other opinions, the Big Splash hypothesis is wrong. This disproves the Big Splash hypothesis, which suggests that the Moon was formed by the collision of two planets much larger than Mars, after Earth was the first planet to form. And the Moon was formed from disk debris around the planet. Are considered to be wounded. According to the Big Splash hypothesis, there are different hypotheses about the chemical composition of the Moon. According to some analyses, the chemical composition of the Moon is considered equal to that of the Earth and Theia, that is, the Moon has a well-melted composition of the rocks of the Earth and Theia at high temperatures during the big collision. According to other conclusions, the share of Theia in the composition of the Moon is said to be 80%. On the contrary, according to the conclusions, the share of the Earth in the composition of the Moon is 80%. Another inconsistency about the chemical makeup of the Moon related to the Big Splash hypothesis is the volatile elements. Carbon emissions were found on the surface of the Moon. Water ice has also been found in the sunlit areas of lunar craters. But the Big Splash hypothesis remains the most popular hypothesis for the formation of the Moon. Another interesting aspect of this hypothesis is the impact of Theia on our planet, which leads to the conclusion that our planet has had many collisions with massive bodies like Theia. This means that our planet is formed from an alliance of planets like Theia. At a time when people are dreaming of going to Mars, we are already walking on several planets like Mars.